Welcome to Rex Arthur TV. This is the Rex Arthur Show where we discuss LGBTQ issues with an LGBTQ approach and an LGBTQ perspective and a humanistic approach in an LGBTQ plus planet where each and every one of us belongs to one or two letters in the 10-letter sexual alphabet LGBTQIAAP. And today we're going on with part two of the polar blast in USA and the summer storm in Australia, showing you the weather extremities that are highly blamed on climate change. And we had said we're going to be talking about climate change and cosmology this year more than ever, because even as LGBTQ persons, we are concerned about our LGBTQ plus planet. Remember, very many animals are also LGBTQ plus. It's beautiful, isn't it? The chimpanzees, the lesbian chimpanzees, and the other sea creatures that are homosexual and bisexual and transgender. It's just lovely. We live in a diverse world, and that's what you've got to understand. Now, we were discussing in part one, we were discussing the climate change not the climate change, we were discussing the evolution of the earth and the fact that every life form goes through change. The reason why the temperature of the world is always changing, climate changes, is because the world or the earth is a life form. And life forms go through changes over a period of time. That's why evolution is true on the basis that the humans of yesterday are not the humans of today for one reason, because the environment they lived in was different from the environment we live in, and the environment we live in will be different from the environment people are going to live in the future. So because of that, life is a combination of interconnectivity between other life forms. That's what life is. That's why it's very complicated to understand the life in the world, because the reason being sorry about this, I'm trying to set this camera very well. The reason being, the world is okay. I was losing my thought. Okay, I was trying to say about the complexity of understanding life in the world is based on the fact that life forms, the life forms are connected to each other. You see, the earth is connected to the life form called the sun in a system called the solar system. And the earth is a system, the sun is a system, Mars is a system, Venus is a system. It's like the body. We have the circulatory system, then we have the nervous system, and then we have the the skeletal system, and then we have the lymphatic system, and then we have the what else have I forgotten? What else have I said? Lymphatic system, of course, the muscular system. All of these systems are connected together in the body. Now, even the solar system is a cosmological body. It's like a human body. And there's a solar system that is connected to the Earth system, that is connected to the Venus system, that's connected to the Martian system, that's connected to the Mercury system. All of the planets in the solar system are systems within a system, just like the body is a multi-system cosm. Now, because of all of that, life of one system affects the life of another system. That's why when you fall sick, when somebody when you've done a lot of gym work, your muscles get tired because your circulatory system has been working overtime, and your nervous system also is working. So when you go to the gym, all these systems are working. And when somebody injures you, like cuts you, and you start bleeding, all the systems in one way or another are affected, but depending on the proximity to a system, the significance of the injury is greater. If it's close to you, like if I injure your face, most of the parts that are close to the face will be affected by the injury. But if but my feet will not be affected because they are very far from the injury. However, if I put a bomb on my body and I blow up, my feet will also be injured because the impact of the injury is so big, or the effect of the injury is so big, that that my feet cannot run away. They are so close to the injury of the bomb because of the power of the bomb. So the bigger the change, the more systems are affected. The smaller the change, the fewer systems are affected. So the reason why we are looking at like this climate change happening to Earth, we need to discover and find out what is happening to the temperature in Mercury, what is happening on the temperature to Venus, what is happening to the temperature in Mars, but mostly Mercury, Venus, because Mercury and Venus are closer to the sun than the Earth. Now, if you find changes that Venus is also changing because of climate change or because of the sun, then we can say as climate scientists that it's actually there's a significant changes to the solar system are being accelerated or pushed by the sun. But if you look at Venus, and Venus has remained the way it has been for quite some time, but Earth has changed drastically, then we will not blame the sun for climate change. Then we will blame put blame to the earth, to the earth. Now that's what I want us to discuss in this second part. Why is it that there is a lot of climate change in the world at this time? It is because climate change, first of all, as we said in part 1, is natural. The climate of the world will forever change as long as the world is there. Reason being, its life form is connected to the sun, which also changes because it has life. The sun has life. And it has a beginning and it will have an end. It will die. So now, because of that, the earth has always been changing, because as we said in part 1, the earth is 4.5 billion years. Now I want us to see how old the sun is. How old is the sun? The sun is 4.6 billion years. That's what they say. Now let's read what Wikipedia has to say. The sun is a star at the center of the solar system. It is a nearly perfect sphere of hot plasma with internal convective motion that generates a magnetic field via a dynamo process. It is by far the most important source of energy for life on Earth. So it's an energy source. And it accounts for 99.86% of the total mass of the solar system. Can you imagine? 99.86% of the total mass of the solar system is the sun. Roughly, 3/4 of the sun's mass consists of hydrogen, that's a gas. The rest is helium, another gas, with smaller quantities of heavier elements including oxygen, another gas, carbon, which are gas, neon, and iron. Now, of course, these are gases. the beauty of the elements of the periodic table, chemical elements, is that some things can be solidified and liquefied and gaseous, like iron, carbon. Carbon can be solidified, it can be in solid form, it can be in gaseous form, like carbon dioxide, and then it can be, in gaseous form it can be like that, and then you can have carbonated water, like what you drink in the sodas. They are carbonated. So that's the beauty of the chemicals, that chemicals can have, what do you call it, they can exist in more than one state of matter. Now, back to what I was trying to say about the earth, because this video is about the sun and why there's climate change in the earth. Now, you've seen the sun is 4.6 billion years old. You've seen the earth is 4.5 billion years old. So according to scientists, the sun came first before the earth. And that can make sense because the earth belongs to the solar system, to the solar system. But I've told you, the Bible scholars, or the people who wrote the Bible, they are geocentrists. They believe the earth came before the sun. That's the belief that, or at least when you read the Bible, Genesis chapter 1, the account of Genesis chapter 1 says that. But when we discuss Genesis chapter 2, Genesis chapter 2 is the second account of creation. That is not the same as Genesis chapter 1. And that's what people need to understand. The Bible has two accounts of creation. One is a bit organized in terms of time, and the other one does not mention time. It just mentions that man was put in a planet called the earth. But we'll look at that when we're doing theology. Now, what I want us to say, and it's just a simple thing and then the video is done, is that the earth went through changes when man started industrializing. So the industrial age, let's see the industrial age and climate change. So I was saying to you that climate change has always been happening and will forever happen. But what makes climate change big right now in our time, see, this is global warming, is a long-term rise in the average temperature of the Earth's climate system. So a long-term rise in the average temperature of the Earth's climate system. It's an aspect of climate change shown by temperature measurements and by multiple effects of the warming. Now, this is what I like about English and what they're explaining. Global warming is an aspect of climate change. Climate change forever happens, but what we are going through is called global warming. Now, why did global... I am liking what this article is saying, that in modern context, the terms global warming and climate change are commonly used interchangeably, but climate change includes both global warming and its effects, such as changes to precipitation and impacts that differ by region. Yeah, even I think it's not right to say global warming is the same as climate change, in my view, because reason being the reason being the earth has always been changing its climate, because over time the power of the sun has also been changing. The sun is also evolving. Everything evolves. Anything that has life evolves. Even the earth is evolving. So because of these changes, the earth will also change. Just like your body. I told you in the other video, we are systems, and the solar system is a system with systems. So when there's a change in one system, there'll be a change in another system, and there'll be a change in another system. So that's what happens to earth. Because the sun is also changing, the earth will also change. Now, the problem with global warming or human catalyzed climate change is that the earth began to do what is called the industrialization of the world, something that has never happened in the history of the world ever since humans began. Because when humans were, industry has been there, but not the industry we have been having today. Today's industry, coal industry and mining, but mostly coal, it has never happened before. The farthest people were using, the farthest energy they were using to industrialize the world was fire. The fire energy, that was the farthest. So even fire, when it burns, the smoke will create carbon monoxide, but it's not enough smoke to go up into the atmosphere compared to coal. Coal, when you burn coal, it is, first of all, coal is carbon. So the carbon emissions are more when you burn coal, when you burn fire. So what came to the industry of man was coal energy. And this is what you want to see. Look at this, 1880. You see, the global land ocean temperature index, it has been increasing. You know, look at that, the concentration of carbon dioxide from the year 2000 and to 2100 is predicted to go that way. Look at that. Unbelievable. Look at, again, temperature anomalies over land and ocean from 1950 to 2020. Look at the medieval warm period. This is what I was telling you, the evolution of the earth and the change of temperature. So medieval warm period, and then there was a little ice age in the 1600s. Then it went ballistic in the 1800s. Now, I want us to go to the history. So you see, the greenhouse effect is a process by which absorption of emission of infrared radiation gases in a planet's atmosphere warm its lower atmosphere and surface. And it was discovered in 1824 and in 1860 by John Tyndall, and was first investigated quantitatively by Svante Arrhenius in 1896. So people have been talking about the emissions, and let's finish here, and then we're going to go to part 3. This graph shows annual gas emissions in 2010 attributed to different sectors. AFOLU stands for agriculture, forestry, and other land use. Emissions are given as a percentage share of total emissions measured in carbon dioxide equivalents using global warming potentials from the Intergovernmental Panel on Climate Change's second assessment report. So 9.6% is produces carbon emissions of other energies. Industry produces 21% of the carbon emissions in the world. Then transport 14%. Then followed by buildings 6.4%. And then our agriculture, forestry, and other land use also is higher than industry, 24%. And the highest emitter of carbon is the electricity and heat production industry. That is the one that's causing the highest form of carbon emission. Electricity and heat production. Now later on we'll break down and study how those things do it. Then you can now see the countries that have been the carbon emitters. This bubble diagram shows the percentage share of global cumulative energy-related carbon dioxide emissions between 1751 and 2012 across different regions. So America, 26% is the highest emitter of carbon dioxide is America, USA, and it's there. They are the most industrialized, the most capitalist country in the world. So that's capitalism for you. It's very busy, very, and I'm going to on part 3 I'm going to talk about the power of industrialization on the climate of the world. Now, look at that. USA 26%, followed by China. Of course, no, not China. The rest of Europe and Eurasia, 16.4%. Then followed by China, 10.7%. That is almost less than half of what America is doing. And then you have Germany and Russia and UK trailing together. Then you have Canada, and then you have South America and Central America. Then you have ships and air travel, 3.7%. And then you have, of course, because steamships, they also release smoke in the air. And then you have Japan, 4.4%, and then same to rest of Asia Pacific. Then you have India, and then you also have the Middle East, and lastly you have Africa at 2.6%. And like Africa is the least industrialized continent, so it's going to it releases little carbon dioxide. So the less the industry, the less the carbon emission. And now, how do you want to know there's less industry? Look at what I mean. This means Africa has little industry, Africa has little transport, Africa has few buildings, Africa has little afolu, that is agriculture, forestry, and other land use. Of course, Africa has a lot of forestry, forest cover, and agriculture, but basically it's not commercial, and not a lot of commercial farming. And then Africa has little electricity and heat production. In fact, Africa depends on the sun more than for many other things, like now solar energy. So, and as I told you, buildings, we don't have very many buildings compared to the West. And you've seen who is leading in carbon emissions. It's countries that have industrialized, countries that have buildings, countries that have so many cars, countries that have very little very little natural vegetation. That's what's happening. Okay, we'll come to part 3.